I'm Joe Ottinger. I'm one of the editors for the server side way back when.
What's good about Java 9? There's a lot of goodness coming in Java 9. It's faster.
In what way?
Smaller.
What makes it faster?
Stronger. It's just the overall incremental improvements that go into the JVM pretty much on a daily basis that just get rolled out with every release. Every release gets faster because the geniuses, the hotspot engineers, well, they are geniuses actually.
They are, yes.
Keep doing amazing things to make it more stable, faster, more features. Just it's just a better engine day in, day out.
Okay, so that brings up a good question. Now, are these performance increases incremental, or they're not dramatic, right? They're just like it's faster because it's the new release and new things go in, right?
Well, some of the things actually. Okay, so I run a performance tuning workshop. I think most people know that, and as new JVMs come out, I have to keep adapting the material to the new JVMs. So I keep rewriting stuff And over the years, what happens is that we get exercises that just get, the effect that we used to see just goes away. So I'll go from like Java 6 to 7, and then I lose an exercise because, whatever part of the JVM it was irritating to cause some performance bottleneck it's gone.
Right.
And it's no longer an issue. And you go to 6 to 7, same thing happens. 7 to 8, same things happens. And when you start running things in 9, you just see that different things happen. And I do this other talk. It's basically I call it my magic act, where I get the audience to tune an application for me.
Right.
And again, I've been doing this for a couple of years. People seem to like it. It's my cheap drink thing. And yeah, it's fun, right? The audience likes it because basically they're driving the demo. But the one thing I've noticed is that over the years, the performance target that I give the audience has gone down. It used to be like about 4 seconds, get the little micro benchmark to run in 4 seconds. Now it's 2 seconds. So the same code, no changes to the same code. We don't do anything differently, right? All I'm doing is just changing the JVM from version to version. It's not really a garbage collection issue because there's no garbage collection issues running in the whole thing. So it's just, better optimizations coming from hotspot, things like that, and you just notice it. It cut the runtime down by half just over the years. So little by little. So
from that perspective, the rapid turnover from 8 to 9 to 10 to 11 to 18.3, whatever. But is that like a harbinger of that kind of incremental performance on a regular basis?
Yes and no. I mean, I think, if you went to Mark's talk, or if you've been to one of Mark's talks where he explained what's going on, it's basically the delivery model is completely changed. It's what's ready goes in. Excuse me, and it's the releases are fixed. So if you're not ready, it's like
it just gets left out.
It's the next one, right? So I think what happened with essentially 9 and like 10 is that there was just a fat pipeline of things that were coming in. But I think over time, I don't think you can't maintain that pace of new features. So I think what will happen is that you're just going to see like a nice incremental amount of change coming in. I think Simon Ritter had a talk. He does this 55 things and new things, and his joke was next for Java 10 or 11, it's going to be like the 5 new things.
Well, even that's better than no new things.
Well, excuse me. I think it's actually better than 55 new things.
Right.
I know it's going to be more than 5, but
right.
That's a joke. But it's actually better because because the incremental jumps that companies have to make as they upgrade their stack is going to be smaller, which means that they're going to be able to keep up with the JVM.
So you don't think that the end of lifing of 9 and 10 in its turn, you don't think that's going to be an issue for
No,
people?
I don't think so. Maybe early on it will be, but later on, once we get used to the pace,
Right.
no, it'll actually be better. It'll help companies move up the stack faster, so they'll be able to stay more current. It's going to be really hard on the. Right now, it's hard on the tool vendors because 9
Right.
represented a huge change.
Right.
And so the tool vendors and everybody are just like, we're still reeling, trying to catch up to that. And we're not caught up. And 10's coming out.
Right.
But the change between 9 and 10 is minuscule.
Right.
And I imagine the change between 10 and 11, I imagine it's going to be like so small. Also that we'll have to make some adaptations, but it's going to be a much smaller gap, which means that we'll be able to move up the stack without any issues.
Well, we know that with 10, there's some changes in the module, in the default module namespacing. So, like some of the Java EE modules are no longer being exposed to the default namespace.
Right.
What other changes does 10 have?
That's a good question. Actually, I honestly don't know because I haven't been paying attention. I know there's some small languages that change. I mean, the changes I've been tracking are things like value types.
Right.
Okay.
Which is a pretty big change.
It's a big change for the runtime, but it's not really a big change for anything else. Not for the language.
Okay, so
var handles and things like that were they're a big change, but not for everybody. There's all these changes, small changes, but they don't really affect everybody.
Well, as a coder, how do value types affect what I'm doing?
They don't.
At all? I mean, I can't write a value type thing.
Well, you could, but it explains it perfectly, right? Brian says it perfectly. He just basically said, performs like a primitive, behaves like an object. Well, he didn't say it that way. He says, looks like an object, behaves like an int or something like that. But that's his message, right? And that's really the way it should be. It's like we're going to take all of these things like strings, and they're going to be primitive types. Rip out the header. Do you ever see a header?
No.
So what do you care?
Well, I'm just kind of as a platform guy, I'm like trying to think how is this going to change. I mean, like, how is it going to change the performance of what I do? And also, because I use a lot of alternative languages like Kotlin and Scala. Scala? It's an ongoing joke. It's
Scala. I don't know.
How whenever I mispronounce it, people have to take a shot. So, readers.
Is it relative? Relevant, I should say.
What the pronunciation is?
No. The language. Okay,
well,
no, just kidding. Okay, so
I'm lost now.
Never mind. I can do that to you. So
you can. No, I'm back.
But it's at the end of the day, what you have is an engine that executes bytecode.
Right.
So however you produce the bytecode, not my problem.
Well, I was just thinking, like,
just give me bytecode.
When you look at languages like Kotlin that doesn't have a primitive, doesn't have a model for primitives. It just says, look, it's an int, it's an object. Do you think that languages like that, especially over time, because they'll have to catch up too, do you think that languages like that will see a benefit from value types at all, or do you think it's just going to be transparent?
I think this is going to be a very transparent change. I don't expect.
Okay, then why do it? If the change is transparent, why is it valuable?
Well, okay, because really, what we're trying to do is reduce memory footprints.
Okay.
Okay. I mean, do you really need more than one? Yeah, but having more than one takes up memory.
Right.
So why not just have one and don't bother taking up all that extra memory?
We could go into like a metaphysical discussion of what a one really is.
Yeah.
And then there's a reason for it, because a one might be a one in integral concept, but not a one in perform. I'm not prepared to have this discussion right now. Thank you. But
neither am I.
well, I mean, like when you look at a 1, the vertical slash that represents a 1 for most people, a Unicode 1 is not the same as a real 1. It's a numeric 1. It's kind of where I'm thinking. So the different representations have value, but maybe they don't. I don't know. I'm still kind of wrapping my mind around the utility of, like
you get. Well, it's a reduction in memory. It's exactly what it is.
On what factor?
Well, first off, you're going to lose the object headers. That's 42 bytes for everything, right? That's 42 bytes of overhead you lose. And
you lose the flyweight stuff for it, presumably, like the integer, the flyweights for.
Oh yeah, okay. Well, you do lose the level of indirection,
right?
Which is never a bad thing. So I think there's some benefits that are coming from. I mean, the bigger issue is that we really would like more control over layouts of memory, so that you can take better advantage of the advances in prefetching and things like that inside the CPU. And value types is sort of like what I would call the first step on the road to giving people more control over how data is laid out in memory.
All right, here's another question for you, because you're giving me all these little thoughts that run around in my head, and I'm not used to that.
Okay.
How many what percentage of Java coders, and just, look at the rank and file, how many of them know about or care about memory layouts?
How many of them know about or care about the memory layouts?
I mean, we're talking about like just the ordinary Java coder, like
I have no idea. I don't think people really care that much about data layouts when they're in their cube, like trying to crank out their application or whatever it is that they're doing. But I think framework developers do.
You think that linked lists will finally be useful?
Was it ever useful?
Well, not in Java.
Yeah, well, yeah, exactly. Sure. No, it's of course there's uses for linked lists. I use them all the time, but
it's a running joke. Well, I mean, when most people need
must be an insider joke there.
Well, not really, because look at if you need a list, most of the time you go for an array list, because you don't have memory fragmentation. You have faster speed because it's an array access for the reference, and
well, it depends on what you're doing, right?
Always.
But I mean, if you're doing something FIFO or LIFO, then
well, I mean,
an array list isn't actually going to work, right? So it depends on the operations that you want.
Well, always. I mean, there are going to be uses,
right? But so that gets into what does your data layouts look like, right? How are you going to? Anyways, data layouts are important. They're going to be important to people writing frameworks, and there's all kinds of stuff down there. I mean, I just looked at a friend of mine. He did a talk where he mentioned value types in the whole thing, right? And I said, okay, how many real developers are going to actually use value types, right? And well, they're all going to use it, but they're all going to use it unwittingly. Right. So they're not going to know they're using it. They're just going to use it, and that's fantastic. That's perfect. That's what you want. Right. I mean, I just want to write code. The performance issue or the representation issue, that's somebody else's issue.
Right.
And if they come up with a better way of representing things, and it gives me some performance benefits, and I don't have to do anything for it, then
everyone wins.
Everybody wins, and that's really what it's about. Yeah.
So, next question: Java 12 is going to get rid of null pointer exception?
That's new to me. I haven't heard that.
You won't hear it. It's a terrible idea, but I mean, I just think it would be kind of fun to try to rename a basic exception type.
How they? I'd have to think about that.
I'm making it up.
Oh, okay, that's good. I mean, not throwing null pointer exception seems like a great idea, but
well, yeah, but renaming the null pointer exception would be
that doesn't really, that's basically putting a cherry on the lipstick on the pig, right?
A cherry on the lipstick
on the pig, yeah.
We just angered Peter a whole lot, I think.
Okay.
maybe.
Cool. Anyways.
So Java 10 doesn't change much from the coder's perspective, right?
I don't think so.
Do you see modules growing in acceptance?
For legacy, probably not, but for new code, I mean, we asked the question to, basically, I like really modular code, and I tend to write in a very modular style.
Right.
And I mean, to the point where we just took my desktop application and we ported it into Vertex for whatever reason. And it took about 2 weeks to port the whole thing. Right? Most of it was just fixing tests.
Right.
The port. And because really a vertical was a module, and I was like, oh, okay, I just have this thing extend abstract vertical, and boom, I got a module and everything. Well, basically, I have a vertical, and a vertical just happens to translate very well down to a module. So the next logical step for us is like, okay, well, do we actually make a module out of this thing now? And so far the answer is nah. Right? We don't really have motivation to do the extra work to make modules out of these things at the moment. But that's not to say that I can't see a point in time where we would say, yeah, you know what? Probably we do want to make modules out of these things because we want to share these different components with different projects. And that's essentially what we're doing now. I mean, the reason why we're going to Vertex is because we have different projects that are using the verticals. Right. So you're reusing them. So effectively, we're using modules anyways.
That actually brings up another interesting thought. Okay, so I've been part of Java EE for
ever.
Yeah.
Okay. Almost as long as me.
Yeah, back in 2002 with Orion was kind of when I got started on it.
Yeah, I think it was 97 when I was reading the .72 spec.
Yeah, I did stuff with San Francisco though, so with IBM's.
This is a good pissing match.
It is. I think you'll win.
Okay.
Sorry, I had to throw that out there. Yes, San Francisco.
That was good. That was a funny project. Okay.
It was weird, but anyway. So, for one thing, Java EE is getting renamed, rebranded or whatever, which is all fine and good. But the thing for me is I don't do Java EE development anymore. I mean, the actual platform.
Yeah.
I use the APIs a lot.
Mm-hmm.
But the platform itself is nearly irrelevant for me now. You mentioned Vertex. Spring Boot's out there a lot. I do a lot of stuff with Drop Wizard, which is actually my main go-to platform right now. There's RX Java.
Yeah, there's the reactive libraries, yeah.
Yeah, and there's akka and RX Java.
Yeah.
I'm sure that I'm missing a whole lot of them. Do you think that fragmentation is good, or what do you think about the fragmentation? Let's put it that way. Is that a positive or a negative or a thing?
Fragmentation is awesome.
What do you think it means long term?
It means that people are exploring. People are still investing. People are still growing the space. That's what it means.
And that's really kind of cool because when you look at C, C never really had.
Never did this. But the language really didn't. C++. The languages don't really facilitate this type of experimentation, like this mass social experimentation.
Well, I mean, I think that they did, though. I think that it's actually the other way around. I don't know. I mean,
no, it's very difficult to adapt components, C++ components. Cameron Purdy did a really nice talk on this a couple of years ago, as a keynote. And it was basically, C++ versus Java. Why did Java win, essentially? And a lot of it is that. Why did Java win? Well, it won on managed memory, it won on lack of pointers, it won on, I can take a component from you, and I don't have to worry about it completely, bombing or really corrupting or messing up my runtime in very devastating ways.
But see, that kind of goes back to my original thought, because I think that one of the strengths that Java had against C++, one of the things that made that talk possible, not null pointers.
No pointers.
But I think that actually Java EE being a fairly monolithic spec was actually a real strength for a long time. Because if you needed to do a request response, I think that's secondary to my thought line.
I'm sure it is, but I think it's really trivially simple. You don't need to think deep about it. It's just no pointers. That made a whole bunch of different things possible that are, guarantees and things that you just can't make when you have pointers. As soon as you start exposing pointers, all bets are off. I've seen this in languages on just about every single platform that I've worked on, right? As soon as you introduce the concept of pointers into the language on the platform, you just have, everything just is different.
Okay, so look at Python's inroads in AI, or NLP and data science.
Sure.
Java has not had the penetration on data science that Python has for a lot of different reasons. But one of them is, well, the lack of pointers, the lack of direct memory access and pointer arithmetic for quick data traversal. I mean, it's just
you mean against Java? That's against Java,
right? So, do you think that? I mean, how do you see Java? For one thing, is that a goal worth achieving? For another, do you see Java doing it? And for yet another, how? Or is the assertion itself broken?
I think it's a good question. I think it's like a very long discussion. But I think it's. I think all you have to do is look at the trading community and trading strategies being written in Java, and you realize that obviously you can do all of this stuff very easily.
So you think it's a matter of Python having easier integration with C libraries to do all the work, as opposed to Java not being suited for it?
No, I just think it was just. I'm not sure exactly why, but my guess is it's more of an emotional choice than it is actually a technological choice.
It could very well be.
I think so.
I mean, I've done a lot of AI in Java, obviously. Well, maybe not obviously, but I have.
Right.
And most of the NLP stuff that I do is in Java, so clearly it can be done, but the libraries are kind of old now is the biggest problem. Is all the new development work is being done in Python, and I kind of resent that because Python kind of bites. But
well, look at H2O, written by Cliff Click.
Yeah.
There you go. Okay.